All right, let's talk about compounded interest problems. So, suppose that you deposit $3,000 in an account that earns 3.8% interest, annual interest, and you want to calculate how much would you have in 5 years if that interest is compounded continuously. Now, one of the things you have to do with problems like this is you have to convert the interest rate to a decimal. So that's going to become 3.8% becomes 0.038%. So, so as a decimal, 0.038 as a percentage. That's how you drop the percentage sign and you move the decimal two places to the left. So we'll use that. First of all, let me just explain that compounded interest is when you calculate the interest and you add it back to the account. Now, I'm 59 years old. I've never gotten a loan where the interest was compounded continuously, and I've never invested money where the interest was compounded continuously. So I suppose it's a thing. It's certainly a thing in our math textbooks, but I don't know of an example in the real world where they compound the interest continuously. Now, if somebody was calculating the interest and you had to pay it, that'd be a bad thing because they're calculating the interest and they're charging you each time. But if it was an investment, it'd be great. I'd love to have my interest compounded continuously. That would be wonderful. Maybe there are some investments like that. Hit me up in the comments. Let me know if you've ever seen anything like that. I've never have. Usually the interest is compounded on a monthly basis or on a quarterly basis or something like that, an annual basis. So we'll talk about that as we do it. But let's deal with this problem because I've seen these in textbooks for years and years and years. And so the formula for that is A equals P times E raised to the RT power. So P here is the principal, so that's going to be $3,000. So I'm going to put that in first. And then E is an irrational number. It's about 2.72. It goes on forever, kind of like pi, never repeats. We'll use our calculator to do that, though. We're not going to use an approximation. We'll use the E button on the calculator because we don't want to round it off. We want it to be as accurate as possible. So it's 3,000 times E raised to the R, and R as a decimal is 0.038 times T, which in this case is 5 years, power. So the accumulated amount is going to be equal to that. So let me swap over here to the graphing calculator, and I'm going to type that in. So 3,000. So I type in 3,000. Now watch the excuse me, watch how I can get the E on there. So I want to get 3,000 times E. So what you do is you hit second, this blue button, second, and LN there. And that, notice what that's going to look like. So it gave me the E there. And then I want to raise that to the, and I'm going to put it in parentheses, 0.038 times 5 and close the parentheses like that. So that's what it looks like so far. All right, so let's zoom in there just a little bit. There you go. So it looks like that. So if I hit enter, I can see that it's going to be $3,627 and about 75 cents rounded to the nearest cent. So what this means is if you put $3,000 in an account that earned 3.8% interest, that if it was compounded continuously, in 5 years, you would have earned over $600 in interest that would be added back to your account. So your account would not have $3,000 in it, but it would have $3,627 and about 75 cents. So that is continuously compounded interest. So the formula is A equals PERT. PERT used to be a shampoo. I don't know if they still have PERT shampoo, but it was a shampoo years ago that had both shampoo and conditioner all in one bottle. It was a green bottle. So that's the way to remember that formula. For compounded interest when it's compounded continuously, it's A equals PERT, P-E raised to the R-T power, continuously compounded interest. All right, let's talk now about a similar problem. So suppose you deposit $3,000, so still $3,000, and it's an account that earns 3.8%, which was just like in the other problem. It's annual interest. But this time, let's suppose that the interest is not compounded continuously, but it's compounded quarterly for 5 years. So 5 years compounded quarterly. So let me put years here. So 5 years. So we did 5 years a while ago, but the interest was being compounded continuously. Well, this is the formula for interest that's not compounded continuously, but compounded quarterly or weekly or monthly or annually or something like that. So the accumulated amount equals P times 1 plus R over N raised to the NT power. So in this problem, the principal's still $3,000, so I'm going to put $3,000 there. 1 plus the interest rate written as a decimal is 0.038. If interest is compounded quarterly, that means it's compounded 4 times a year. So N is the number of compounding periods in a year. And this is the same N up here. So I have 4 here and 4 there, and it's 5 years. T is the number of years. So let me swap over for a minute to this calculator, and let me put that in. So 3,000, you got to be careful typing this in, 3,000, and then in parentheses, 1 plus, and then I want to do that fraction in parentheses. So notice it's 0.038 divided by 4. So look, I'm going to use parentheses, 0.038 divided by 4, and then close the parentheses. And then I'm closing that parentheses again. So this is 3,000 times 1 plus, the fraction is in parentheses, and then I close the bracket there. And this is raised to this, so I'm using this caret button to raise it to the power. So raised to the, what is it, 20th power, because 4 times 5 is 20, so raised to the 20th power. I'm going to type that in like that and hit enter. So notice that's $3,624 and what is that? 50 cents. 50 cents. Rounded, because if you have 0.496, because of that 6, you're going to round that 49 to 50 cents. So what I have here in the calculator is the amount of money you would have after 5 years if the interest is just compounded quarterly. This is what it would be if it was compounded continuously. So notice it's about a $3 difference. So there is a benefit if you're earning the interest. There's a benefit to the interest being compounded more often. So continuously is more often than just every quarter. So it's a little bit of difference, but if you had a higher interest rate and more money to begin with and a longer period of time, there'd be a greater difference. So generally you want, if you're the one that's earning the interest, you're not paying the interest, you want it to be compounded more often. If you're paying the interest, you don't want that because it's going to be more money that you have to pay. Anyway, there you go. So there's a problem where you have interest being compounded continuously. And now this one here where it wasn't compounded continuously, it was compounded quarterly. And that's the formula that you use when the interest is compounded, not continuously, but something else. So A is the accumulated amount if you're earning the money. P is the amount of money that you started with when you first invested it. And then it's 1 plus R over N, R being the interest rate as a decimal. So it was, that got converted, 3.8% became 0.038%. Quarterly means 4 times a year. If it was annually, N would have been 1. If it was semi-annually, N would have been 2. If it was weekly, N would have been 52. So forth and so on. If it was monthly, if it was compounded monthly, N would have been 12. But it was quarterly here, so N was 4. And then we have raised to the 4 times 5 power, which is 20, because N is 4 and 5 is the number of years. So 4 times 5 is 20. So that's how much money would accumulate there. All right, so that's a little bit with interest, compounded interest.